Yet another entry in the Hammer Strength Isolateral series. This one, an isolateral leg extension. Which again, I think knee extension makes more sense, but whatever, you know, what do I know? Now, this is the first time I've actually ever encountered one of these machines in real life. You know, seen pictures of them and whatnot. But as you can see, there's just a fixed pad here that you would push into with your knee to extend out, and you know, it's just all one fixed piece, and you would attach your weights down here. It's kind of an interesting thing because you notice you can attach them at two different points, so you know, you can actually change a little bit of the resistance with the same amount of weight. If I put a say 45-pound plate here, it would be different from putting it right there on the other bar, because I'm changing the distance between that and the axis. But what I wanted to show you though is something that I think is a little bizarre. Is that, again, this is fixed. There's no cam. All we have here is a free-floating lever, and of course you can see there's the axis right there. Now, if you were to see one of these in the gym, you could walk up to it, just put your hand and start moving it, and at first, especially if you're right on the end here, it doesn't take a lot of effort, you know, I don't know, 5 pounds or so to move this thing. And the other end, of course, because it's all one fixed piece, will start moving. But if you push on this with constant force, it'll move at first, and then it gets harder. You have to generate more force to get up here. Why? Well, look at the distance between just the weight of the system here. This is all coming farther out. Axis is fixed, but the center of mass of this end of it, all of the mass collectively on this side of the axis, is moving farther out. What's that mean? Well, it means that the net moment arm there, you know, if you calculate the center of mass of this whole system, right? If you calculate the center of mass, that's not going to move in terms of where it is along the length of this piece. And that would be the case too if you added, you know, weight plates to these bars. Wherever the center of mass of that whole system with the weight plates would be, that would be the same point along this this lever here. So as you move out, that means that gravity's pull through that center of mass would be gaining mechanical advantage because the moment arm would be getting longer. So we've all seen that before. I think you guys probably understand the moment arm fairly well. But the issue here, if you recall from previous knee extension or leg extension machines that I've talked about, is that typically the quads, as the quad contracts or shortens, as the muscles shorten there and the knee extends, well, those muscles, especially when you're seated, so even, you know, for the rectus femoris, which crosses the knee and hip joint, what you're getting is a situation where those muscles are reaching a relatively shortened position. And what happens to a muscle when it shortens? Well, as it gets towards an extremely shortened or extremely lengthened position, it drops off in force, in maximal force. That means that the maximal amount of tension you can generate in those muscles is decreasing. But what's happening here? As the muscle gets weaker, we are encountering greater resistance. So this thing's getting harder while you're getting weaker. So if you're able to do something with moderate effort down here at the beginning of the rep, by the time you get up here, you may not even be able to finish the rep. And I tried this thing out, and well, one, it's awkward because if you look at the angle of these pads, they're not exactly parallel. They're angled off from each other a little bit, which I guess is to, you know, an attempt to accommodate maybe, you know, a position where, you know, the hips are pointing out slightly away from each other and allowing the knees to track in that direction. But to me, it felt pretty awkward. And then, like I said, the force curve was just kind of crazy. So I wanted to show you that. That's I don't think I'm ever really going to be using this particular machine because, like I said, the force curve or the resistance curve is just weird. And when I think it should be dropping off in resistance, the resistance is actually increasing. Not well matched to the strength curve of any human being I've ever met anyway. But I wanted to show an example of that. And so this is to show you also that just because a machine says it's supposed to work a certain thing doesn't mean it's good at doing that. So that's just some more food for thought. Always comparing these different machines so you can see that not all machines are created equal. Some definitely have advantages and disadvantages.